Hi, everybody. I want to do one more example for you, finding mean, median, mode, and range, just to make sure that you understand exactly how we find each of these values. So here I have another data set, and this time, how many numbers do I have in the data set? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, we have an even number of numbers in this data set, so we won't find a number that's smack dab in the middle. But first things first, let's get them in order from least to greatest. I have some ones here, a couple of them. So I'll write those down. 1, 1. Next, let's see, do we have any twos? I don't see any twos. How about 3? Here's a 3. And then 4, 1, 2 of them. I like to cross them off as I go. And then 5, I have 3 5s, it looks like. 1, 2, and 3. I'll write them down. And I have an 8. Boop, boop. And finally, we have this 20 here. Did I get all of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers. I started with 10 numbers, so I feel pretty good about that. All right, so the mean, median, mode, range. There we go. The easiest of these to find would be the mode. That's typically the easiest one to find. What number appears more frequently than the others? And in this example, there is a clear winner again. We have 3 5s in the data set. No other number appears as many times as that. So my mode here is 5. To find the range, take the high number, 20, subtract the low number, 1. 20 minus 1 is 19. That's a very large range. You can't get much larger than that um, in this particular data set, with 20 being the high number. And let's see, median is the number that's in the middle. So I'm going to, since I have 10 numbers here, let's cut that in half. You could actually look here at the left and at the right, kind of pair them up and go 120, 18, 35, 45, 45. Uh-oh, I'm going to be between this 4 and this 5. Some people maybe have done that before, but I like to say, well, there are 10 numbers, cut that in half. We want to find 5 numbers to the left, 5 to the right. So I have 1, 2, 3, 4, 5 to the left, and over here I have 1, 2, 3, 4, 5 to the right of that line. So I need to average these two numbers. I need to find the mean of these two values. Well, I have a 4 and a 5 here. I bet you know what the average of those would be. Halfway between that would be 4.5. So we have a median of 4.5. Okay. Now, again, you need to really average these two numbers. And if you take 4 plus 5, adding those together, and divide by 2, since we're averaging those two numbers, 4 plus 5 is 9, and 9 divided by 2 does equal 4.5. Okay, so the median is 4.5. We like to use decimals when we're analyzing data sets. So I know it's the same as 4 and 1/2, but 4.5 would be a better way to express that median. Now the mean, or the average, is found by adding these all together, and in this case we'll end up dividing by 10 when we're done, because we have 10 numbers here. Okay, you can use a calculator to add these together, but again, I think I'll do it mentally just to save some time. 20 plus 8 is 28, 33, 38, 43, 47, 51, 54, 55, 56. And then we divide by 10, since we have 10 numbers in this data set. And 56 divided by 10, again, you can use a calculator. That will equal 5.6, because when dividing by 10, you can just shift the decimal point left one space. This time, notice the mean. Notice how much higher it is than the median. 5.6 is quite a bit larger than 4.5. So here's my median, mean, mode, and range. Now, any guesses why the mean is so much higher than the median here? Could it possibly be, I mean, look at our numbers, 1, 3, 4, 5, 8, and then all of a sudden 20? What is that 20 doing in the list? That is a clear example of an outlier. Remember, outliers are numbers that lie outside of where all the other numbers in general happen to be in the data set. So 20 is an outlier. What would the mean be if you removed it? If you removed that outlier? If I removed that 20, I could subtract 20 from my total of 56 and I'd have 36, wouldn't I? Take that 20 away and instead of 56, we have 36. And now my mean I would find by dividing by 9 because now I'm just averaging these remaining 9 numbers in the data set. 36 divided by 9 equals 4. So I would get a mean would become, the mean would be 4 if you remove that outlier. So having a mean of 5.6 is really overstating where most of these numbers are in this data set because that 20 really pulled the average up in this example. Okay, so by removing it, notice I divided by 9 instead of dividing by 10 now because I removed one of the numbers. But you can see how it affected the mean. You know what else is affected greatly by removing that number? The range. Because now, if you remove the 20, your high score is 8, and 8 minus 1 would be 7. So your new range would be 7. Look how much smaller that is than what we had originally. What you'll notice did not change is the mode. The mode is still 5. And the median is still 4.5 because, well, actually, no, the median changes also because if you removed that 20, now you have 4 to the left, you have 4 to the right of this 4. And so the median changes here as well when we remove that outlier. And now notice when we remove the outlier, our mean and our median here are both 4. They're the same now, whereas they weren't even close to the same before we removed that outlier. But these values right here are the mean, median, mode, and range of this data set if you include every number, including the 20. Okay? All right, I hope that helps. I will see you later.